In the diagram, the line DE is tangent to the circle ABC at the point B. AC is equal to BC, and angle ABD is equal to 62 degrees. And here we have this diagram. Our goal is to calculate the value of angle ACB. That's our goal. Calculate the value of angle ACB. Now, where is angle ACB? Well, we're looking at, let me highlight it. Let me highlight this angle. So let's highlight, they want angle AC, right? Angle ACB, all right? Angle ACB. So what they really want us to figure out is what is this particular angle right here, right? What is the size of this particular angle right here? Okay, and so that's what we have to determine. What is the size of this angle right here, right? The one in the middle, ACB, the same one right here. Okay, so in order to do this, we will use the alternate segment theorem. And the alternate segment theorem says that the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment, which means that if we have this angle here, this is theta, it's between the tangent and the chord, right? That means that this angle theta is going to be equal to this angle in the alternate segment that is subtended by the same green chord. And we know that it's subtended by this green chord because the legs of this angle rest on this chord. And so the same thing applies, right? If we have this particular, let's go on to our diagram and notice that we have the tangent, right? So this is the tangent line, and this is the chord, all right? This chord we highlight in red. So we have the tangent line and we have the chord. And the angle between the tangent line and the chord is 62 degrees. And so that means that that's going to be equal to this angle, right? That is subtended by the same chord that is in red. And we know that this angle is subtended by this chord because the legs of this angle rest on this red chord. And so that means that if this is 62 degrees, this angle right here must be 62 degrees because of the alternate segment theorem. And so the answer here is 62 degrees. Let's move on to the next one. It says calculate the value of angle BAC. Calculate the value of angle BAC. And so let's determine what is BAC. So we have B, right? This is BA, right? And then C, all right? So you have to figure out what is the size of angle BAC. And so in this case, they wanted to figure out what is the size of this angle, right? Okay, so if we notice carefully, this is what they want, angle BAC. So they want us to figure out what is the size of this angle right there, angle BAC. All right, and so let me erase that. So what do we know? Well, one thing we know is that, let me just use a pen. Notice that this angle and this angle right here, they are equal, all right? They are equal. These two angles are equal. And the reason why we know that they are equal is because in this case, we're dealing with an isosceles triangle. And how do we know we're dealing with an isosceles triangle? We know that we're dealing with an isosceles triangle because this side is equal to this side. And how do we know that both sides are equal? Well, we know that both sides are equal because there's a line here and there's a line here, which means that this side is equal to this side. And so since the two sides are equal, the two angles are equal because we're dealing with an isosceles triangle. Now, what do we know about the interior angles of a triangle? Well, we know that they must add up to 180. So what we're gonna do is we're gonna say, okay, 180 minus 62, right? So we're gonna take 180 and we subtract that with 62. And when we do that, we get 118. But we have to take 118 and divide it by 2. The reason why we're dividing it by 2 is because we have to share, right? 118. We have to split it into 2 equal parts, such that both of these angles get the same amount. All right. And so we have 118 and we split that into 2 and 2 equal parts. And so it's going to be 118 divided by 2. And that means that this is 59 and this must also be 59. All right. And so let me erase that. Erase our link. So this is 59 and this must also be 59 because these two angles are equal. So we take 118 and we split it into 2 equal parts. And so that means that this here is 59 and this here is 59 when we divide it, okay? Okay, so that means that angle BAC is 59 degrees. Let's move on to the next one. They want us to figure out what is the size of angle CBE, angle CBE. So let's go here, angle C. Let me use a highlighter. Angle CBE. Okay, they want us to figure out the size of angle CBE. So we are really focusing on this particular angle right there. They want us to figure out what is the size of this angle right there, angle CBE, all right? Now, the good thing about this is that we know that we have 62 degrees, we have 59 degrees, and we have this angle. Notice that all of them are on a straight line, or 3 of those angles are on a straight line, and they are at this common point, all right? So if you notice carefully, these 3 angles right here, they are on a straight line, and they are at a common point. And what do we know about these angles once they're on a straight line at a common point? Well, angles on a straight line at a common point must add up to 180 degrees, which means that 62 degrees plus 59 plus this particular angle right here must add up to 180 degrees. And so that means that we can add up 59 and 62. We're going to take that sum and subtract it from 180 degrees. And so when we do 59 plus 62, that gives us 121. So we have 180 minus 121, and that gives us 59 degrees. And so that means that the size or the value of angle A, that means that the size or the value of angle CBE is actually equal to 59 degrees. And so the answer here is 59 degrees, and that's the answer to this question.